Bismillahirrahmanirrahim. In our today's lecture, we will discuss about the numerical law of chapter number 2, numerical number 2.9. Why does the range of projectile remain the same when angle of projection is changed from theta to theta prime? Here it is a given condition that the angle is changed from theta to theta prime. So first angle is theta and the second angle is theta prime, which is also equal to 90 minus theta. Further, we have to show that the complementary angles of projection, the ratio of r over r prime is equal to 1. So, in first part, we show that the range is same for both angles, and in second part, we show that the ratio of r over r prime is equal to 1. As we know that the range for first angle equals to r is equal to vi square sine 2 theta divided by g, which is equation 1, and the range for second angle r equals to vi square sine 2 theta prime divided by g. By putting the value of theta prime in above formula, we get this: r equals to vi square sine 180 minus 2 theta divided by g. It was also known as sine 180 minus 2 theta equals to sine 2 theta. So the above formula becomes vi square sine 2 theta divided by g, which is equation 2. From equation 1 and 2, it is clear that the range of projectile is same for both angles. Now, we find the ratio r over r prime by putting the values of r and r prime in this formula. We get the similar terms in numerator and denominator, that cuts and equals to 1. Numerical number 2.10. A trolley of mass 1 kilogram moving with velocity of 1 meter per second collides with the similar trolley at rest. So the given data is mass of first trolley m1 equals to 1 kilogram that moves with velocity of 1 meter per second. So v1 is equal to 1 meter per second. As the second trolley is similar to the first trolley, so m2 equals to 1 kilogram, but the second trolley is at rest, so v2 is equal to 0. In first part, we have to show that the collision is elastic, so the kinetic energy and momentum must be conserved in this example. First, we check the momentum. Initial momentum equals to m1 v1 plus m2 v2. By putting the values in this formula, we get pi equals to 1. Similarly, the final momentum, it is given that in this part, after collision, v1 prime equals to 0 and v2 prime equals to 1 meter per second. So, pf equals to m1 v1 prime plus m2 v2 prime. By putting the values in this formula, we get pf equals to 1. Here the initial and final momentum are same, so we say that the momentum is conserved. Now, for kinetic energy, we have to show that the kinetic energy is conserved in this case. So, initial kinetic energy equals to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. By putting the values in this formula, we get 0.5 joule, and final kinetic energy equals to 1 over 2 m1 v1 prime square plus 1 by 2 m2 v2 prime square. And by putting values in this formula, we get 0.5 joule. As the initial and kinetic energy are also same, so we say that the kinetic energy is conserved. Since kinetic energy and momentum both are conserved, so it is an example of elastic collision. Now we solve the part B. In this part, we show that the collision is inelastic. So momentum is conserved, but kinetic energy is not conserved in this case. So as the trolley are stick together after collision, so their total mass is m equals to m1 plus m2, which is equal to 2. Also, it is given that v1 prime equals to 0.5 meter per second. Now, first we show that the kinetic energy is not conserved in this case. So, kinetic energy initial equals to 1 by 2 m1 v1 square plus 1 by 2 m2 v2 square. By putting the values in this formula, we get 0.5 joule. So 0.5 joule is the initial kinetic energy, and the final kinetic energy equals to 1 by 2 capital M V prime square. By putting the values in this formula, we get 0.25 joule. The initial kinetic energy and final kinetic energy have different values, so the kinetic energy is not conserved in this case. Now we have to show that the momentum is conserved. So initial momentum equals to m1 v1 plus m2 v2. By putting the values, it is equals to 1, and final momentum pf equals to mv prime equals to 2 into 0.5, which is equal to 1. As initial and final momentum are same, so the momentum is conserved in this case. Hence, the case B is an example of inelastic collision.